it is Miss Stewart. Today we are going to be learning about food chains and food webs. Now the objective for today is going to be describe food chains and food webs and their constituent members by trophic level. The essential knowledge that you're going to gain from today is a food web and how it relates to food chains and shows flow of energy and nutrients. Then we're also going to touch on positive and negative feedback loops and the roles that they can play in food webs. And the skill that you are going to practice at the end of this is going to be describe characteristics of an environmental concept, process, or model represented visually. We're going to start off with some food web basics. Now, food webs show us how matter and energy flow through an ecosystem as they go from organism to organism. So the matter would be moving and the energy would be moving as it's going from prey to predator or a relationship like that. And the food web is going to show us that movement. So when you have one organism that eats another one, you have the matter, which is going to be your carbon, your nitrogen, your water, your phosphorus, and your energy, which will be glucose, muscles, tissue. The bonds are going to have the energy there. And so when one organism eats the other, that matter and that energy is going to be passed on from the prey to the predator. And when you look at a food web, like this one here, you are going to see a bunch of arrows. Now, arrows in food webs are going to indicate the direction of flow. So they're going to show you from the organism that is being eaten to the organism that is taking in the energy. So the arrows go that direction. I like to think of it as the arrows point into the mouth of whoever is doing the eating. So that's how I remember which way the arrows go. Now, you may have heard of food chains before, and they are sort of related to food webs. They're just different things that they depict. So a food chain is going to show one linear path of energy and matter. So on the left hand here, it's going to go from grass to grasshopper to mouse up to the owl. And then a food web is going to show at least two different interconnected food chains. Now, this example shows you much more than two of them. We have 4 or 5 or 6. We have quite a few different ones here. But you can look if you see the grasshopper to the mouse up to the owl. That would be one of the food chains that's shown in this. And they're all interconnected. So a second example would be going from the plant to the rabbit to the fox. That would be like a second chain besides that first one that I showed you. And then again, that's the first one that I showed you. Now, webs can show that organisms can exist at different trophic levels. When we talked about trophic levels with our last set of notes, we showed the pyramid. And the pyramid's helpful for showing the flow of that energy in the tertiary versus secondary. But one of the common misconceptions is that it's just kind of this linear thing, which again is shown with food chains. But food webs, actually, it's way more complex than that. You can have an organism that can be a primary consumer, but also could be a different level as well. So we can see that with food webs. So an example here is if you look at the grass to the hare to the owl, that you are going to see the secondary. The owl is going to be the secondary consumer in that because the herbivore is eaten, so it's a secondary consumer. However, that same owl can also be a tertiary consumer. So if we look at the grass to the grasshopper to the robin, to the owl now is the tertiary consumer. It's the same owl, but based on different parts of looking at this food web, you're going to see different trophic levels. So food webs show that organisms can exist at these different trophic levels. And what you also start to see with a food web is some of the interactions and then what's called a trophic cascade. So food webs show us how an increase or decrease in a population size of a given species might impact the rest of the food web. And you can use this food web to sort of use the arrows to track through to find a step-by-step of how something might be impacted by a change in one population. So one example of that would be an increase in the python populations. The python's going to be right here. If pythons increase, it's going to decrease frogs and rats because more pythons means it's going to eat more of its prey. So more frogs and more rats are getting eaten, which means their populations will decrease. Now, if the frog and the rat are getting eaten up, that's good news for the grasshopper because the grasshopper is hunted by these two. So if these two are gone, then the grasshopper is going to increase. If there's more grasshoppers, corn's going to decrease because there's more grasshoppers to eat it. So food web shows you all this interconnectedness where it's not just a single organism like, oh, okay, pythons went up. You can go and follow all these other ones that it would impact by following the arrows and making connections in the food web. Oh, I forgot that I had these. So python goes up, rats and frogs go down, grasshoppers go up, and cords goes down. Now, what this is called is a trophic cascade. And a trophic cascade is the removal or addition of a top predator, then has a ripple effect down through lower trophic levels. It's like a cascading effect down that trophic level there. So a different example of this that we have seen actually in Yellowstone is an example of where this happened, where if we see a decline in wolves, that can impact deer, and it can also impact trees. So if we look at this food chain right here, wolves are going to, you've got wolves, which are going to eat the deer here, which are going to eat the trees. Now, this is my bad with this picture. These arrows should be the other way in a food chain. So ignore these arrows if you're thinking in the food chain level. Sorry about that. So what we're seeing is if we end up having the wolves decrease, then the way that's going to impact the deer is the deer are going to increase because their predator just decreased, which means that the deer are going to be more plentiful to eat the trees. So the trees are going to decrease. So the change in wolves can actually impact the trees there. Now, what I want you to do for your practice FRQ for this is I want you to look at this food web that we have right here. I want you to describe one direct effect that a decline in the frog population would have on the food web. And then I want you to identify an organism that is both a secondary and a tertiary consumer. So that's going to be your practice FRQ. And those were your notes on food webs and food chains.